Hey everybody, this is the Introduction to Advanced Computing in Palmetto Cluster. My name is Galen Collier. I'm a computational scientist in the Cyber Infrastructure Technology Integration Group within CCIT here at Clemson University. If you'd like to grab a copy of these slides, they're available in PDF format from this URL. And if you'll be connecting to the Palmetto Cluster from a Windows machine, you'll need to download and install some kind of SSH client. And I'd recommend using this SSH Secure Shell client available for download from the Clemson website or from this URL here in the slide. If you're connecting from a Mac system or a Linux system, you'll be able to connect directly from the terminal window and you won't need to install any additional software. First, I'm going to start off with a little bit of background information about parallel computing and advanced computing. Of course, software is becoming increasingly parallel because the computing devices we're using these days are also becoming increasingly parallel. Even smartphones these days have 2 or 4 processing cores, and typical laptops and desktop workstations have 2, 4, 8, sometimes even 16 processing cores available. So everything is moving toward parallelism, and that's due mainly because of the limitations on processing speed. Processors aren't getting any faster, so we're having to, instead of make faster processors, we're having to build systems with many parallel processing cores. When you run a parallel program, there are sections of the code that can be divided up in parallel. And so those portions of the code will be divided up in the form of tasks amongst the individual compute cores available to your program. Each of those separate processes or tasks can send and receive data amongst the other parallel processes. And if those processes need to communicate a lot for the overall program to proceed, then you'll need some kind of high-performance networking if you're going to be communicating between compute machines, compute workstations. So if your computing needs move beyond what's available to you through a laptop or a desktop machine, if you need more computing time, you need more memory, you need more space, then you're probably moving into the area of advanced computing. And that's when you need a dedicated computing resource to take your research or your computation to the next step. This is a very important step for anybody in research to make, because being able to add a computational component to traditional non-computing research can greatly enhance your capabilities as far as a researcher and how you can investigate systems and communicate your research. When I refer to a local workstation, I'm typically talking about a machine that is made up of 4 to 8 processing cores, typically about 4 to 8 gigabytes of RAM and maybe about 1 terabyte of storage space. An advanced computing system offers hundreds or thousands of individual compute cores, and the individual nodes, the individual compute machines that are part of an advanced computing system offer 16 to 2 terabytes, 16 gigabytes to 2 terabytes of RAM per workstation, per node. And you'll use a system like this to conduct high-performance computing, where you've got many parallel tasks working together, communicating in order to complete some single simulation or computation. You'll also use this type of system for high-throughput computing, where you've got lots of individual tasks that don't need to communicate with each other. And of course, if you need advanced data management systems, if you have very large data that you need to perform computational work on, then you'll definitely need an advanced computing system. So who uses advanced computing? At Clemson University, the Palmetto Cluster started in development in 2007, and originally there were approximately 12 to 15 departments using the cluster when it first got started. Now we have about 36 departments using the Palmetto Cluster, and that's out of about 50 or so departments through the entire university. So a very broad variety of research areas are making use of computing, and specifically the Palmetto Cluster here at Clemson. This plot shows the biggest users of the Palmetto cluster during the past few years. And the data here is presented in core hours over the course of years. And you see that departments like chemistry and mechanical engineering and economics are some of our biggest users. But there we're talking about use in the range of 20 or 40 million core hours. And that's a tremendous amount of computing. But there are lots of other departments who are doing 1 million compute hours. And that's still quite a lot of computing. And they just don't show up in comparison to these other very, very heavy users. So if you've never used a computing cluster before, I want to give you a quick overview of generally how this works. First of all, you're going to connect to a cluster from your local workstation using an SSH client, a secure shell client. You'll log into some user node, some login node. That's your entryway to the computing system. And that machine is connected to all the individual compute nodes that make up the cluster. When you log into that user node, that's the place where you'll set up your job scripts, which are short instructions that tell the cluster how to run your job. That's also where you'll compile code. Maybe you'll prepare your input files and set up your directory structure for running your compute jobs. When you've written a job script, it's basically just a little shell script that provides the instructions for running your computation. You'll submit that job script to the job scheduling system. And that job scheduler will look to see if the hardware that you require for your computation is available. If it's not available, then your job will just wait in the queue until the needed hardware is available. When the hardware becomes available, your job will begin running, and your job script will be used to determine how much hardware you need, how much memory you need, how many cores, how much storage space, all that stuff. And then your job will proceed with running on the compute nodes. Your job may run for minutes or hours or days, and while it's running, it will be reading data from and writing data to the primary data storage system. Typically, this is referred to as a scratch file system, and it's usually a temporary, not backed up file system. And that will be used while your job is in the process of running. When your job is finished, the job scheduler may send you a message to let you know your job is complete. And your data will be sitting in the data storage system waiting for you to log back into the cluster and access that data for analysis or whatever you plan to do with it next. And that's basically it. That's how using a computer cluster works.